Welcome to the Deep Dive.
Great to be here.
Today, we're tackling something pretty core to cloud data, the GCP Modern Data Analytics Architecture.
Yeah, we've got this diagram, basically a map, showing how data flows in this Google Cloud setup.
Right. And our mission really is to follow that map,
Mm.
see the key components,
Yeah.
understand the path data takes.
Exactly. And maybe touch on why it's set up this way, why it's considered, modern.
Okay, let's jump right in. Looking at the diagram, where does it all kick off?
Well, naturally, it starts with the data sources.
Makes sense. What kind of sources are we talking about?
The diagram shows quite a mix. You've got unstructured logs, media files, that kind of thing.
Okay.
And then also your more traditional structured data. Think business applications, custom apps.
So handling both, that seems important.
It's key, yeah. Because real-world data is messy. It comes from everywhere. This architecture is built for that diversity right from the start.
Got it. So you have all this varied data. How does it actually get into the system? What's the doorway?
That brings us to the ingest stage. The diagram points clearly to data flow for this job.
Data flow.
Yeah.
And what's its role, specifically?
It's essentially the intake pipe. It handles getting that raw data, whether it's streaming in constantly or arriving in, like big batches, and prepares it, moves it efficiently towards the core processing engine. It's built for handling, potentially massive volumes.
Right, so it's the heavy lifter for getting data in. Okay, so data flow has ingested the data. Where to next on our map?
Next stop, and it's the big one, is BigQuery.
Ah, BigQuery. I see it's labeled for both store and query.
Exactly, and that's a really fundamental point about this modern approach.
How so?
In older systems, you often had separate places for storage and for the actual computation or querying. You'd store the data, then move it somewhere else to analyze it.
Which sounds slow and expensive.
It often was, especially with large data sets. BigQuery combines these. The data lives there, and you run your queries directly on that stored data.
So storage and compute together. That avoids shifting massive amounts of data around just to ask a question.
Precisely. It's a huge performance booster. The analysis happens right where the data resides.
Makes a lot of sense.
Yeah.
And the diagram specifically mentions how you query that data in BigQuery.
Yep, it calls out SQL, standard query language.
SQL. So familiar territory for many analysts and data folks.
Exactly. You don't necessarily need to learn a whole new proprietary language. If you know SQL, you can pretty much start querying data in BigQuery. It lowers the barrier to entry for leveraging this powerful engine.
Okay, so data sources, diverse ones, flow via data flow into BigQuery. BigQuery stores it and lets you query it using SQL. What's the final piece shown in this flow?
The final stage depicted is present, and the tool shown for that is Looker.
Looker for visualization.
Right. Looker takes the results, the answers you got from your SQL queries in BigQuery.
The numbers, the insights.
Yeah, all that stuff, and turns it into charts, dashboards, reports, things that people can actually look at, understand, and, make decisions based on.
It's that last mile, making the data useful to the business or the user.
Absolutely. It translates the queried data into visual insights.
So if we trace that whole path again, sources in, data flow ingests, BigQuery stores and queries with SQL, Looker presents visually. It feels quite streamlined.
It is. That's kind of the point of these modern cloud architectures, to integrate these steps, ingest, store, query, visualize into a more cohesive, efficient flow.
Reducing the friction between raw data and actual insight.
Yeah, significantly reducing the time and complexity compared to maybe older, more siloed approaches. You can potentially get from data to decision much faster.
Thinking about this, that integration, especially the BigQuery part, storage and query together, it really changes the game, doesn't it?
It fundamentally shifts how quickly you can analyze vast amounts of data.
Which leaves you with a pretty interesting thought. If the technical barriers to analyzing data quickly are lowered this much, how much faster can organizations actually react and make decisions based on that data? Does the bottleneck shift elsewhere?
That's the big question, isn't it? Something to definitely think about.